All right, so this is the second example. So think of an environment, a market environment, where we have only two individuals. All right, so let's think everything very, very simple. So Alice and Bob, these are the two individuals. The thing is, the municipality is going to build a power plant. All right, these two guys need energy to run their cars, houses, etc., etc. And so the municipality is going to build a power plant. Well, the question is, what type of power plant the municipality is going to build? Well, that depends on the participants of this market, Alice and Bob, their preferences. Okay? Well, there are four possible alternatives, let's assume. The nuclear energy, nuclear power plant, gas power plant, natural gas power plant, coal power plant, or oil. All right? Well, green energy, none of those are as green as it should be, but well, anyway. So by the way, this is a very nice example I took from Eric Maskin's one of his lectures. He is actually one of the pioneers of this field, mechanism design, and he got Nobel Prize. So this is a very nice example. Well, once again, these two individuals are actually, and their preferences is important regarding what type of power plant the municipality is going to build. So who are the participants? Alice and Bob. The municipality is the mechanism designer. Well, what about the private information? The municipality is not sure about the preferences of Alice and Bob. So to keep things simpler, let's suppose that there are two states of the world, state 1 and state 2, I call. Well, the municipality doesn't know whether it is the true state is state 1 or true state is state 2. All right? Bob and Alice know the true state because they know themselves, but the municipality or the energy authority doesn't know the true state. Okay, so that's the private information. Well, what is it? Well, the thing is, state 1, if we need a story behind it, state 1, you can think that Alice and Bob do not care about the distant future. They just care about, their immediate future. And in the state 2, they also care about futures, like, how sustainable this energy source is, how it is going to impact their kids' life in the future, and so on and so forth. All right, so this is the mindset of Bob and Alice in state 1 versus in state 2. Okay, Alice is actually caring more about convenience of the energy source, and Bob cares about the safety of the energy source, let's suppose. So the thing is, in state 1, if the true state is state 1, Alice prefers gas to oil, oil to coal, and coal to nuclear. Bob prefers nuclear to oil, oil to coal, and coal to gas. However, if the true state is state 2, this is Alice's preferences, and this is Bob's preferences. Okay? So once again, the mechanism designer, the energy authority, knows the Alice's and the Bob's preferences is this, if the true state is state 1. The energy authority also knows that if state is state 2, well, then Alice and the Bob's preferences are like this, but the environment is very simple. I keep it very simple. The energy authority doesn't know whether it is state 1 or state 2. Okay, that's the only informational asymmetry between the energy authority and the two participants, Alice and Bob. And once again, Alice and Bob knows not only their preferences, but also know the true state of the world. Okay, well, the thing is, the energy authority is going to, if the energy authority knew the true state, state 1 versus state 2, probably the best outcome in state 1 would be oil. Well, why so? Well, clearly gas is Alice's first best, but it's Bob's worst alternative. All right, so we need some sort of concession. Nuclear is Bob's first best, but it's the worst alternative for Alice. So again, we need some sort of concession from both parties. Oil, however, is like second best for both of them. So in that sense, oil seems like a good outcome. Again, if state 1 is the true state. Well, if the true state is state 2, gas seems like a good outcome, right? So building a gas power plant. Why so? Well, once again, nuclear is top choice for Alice, but the worst choice for Bob. And oil is the top choice for Bob, but worst choice for Alice. And so the concession kind of implies that the gas should be the outcome. Coal is not really, it shouldn't be the outcome because, gas strictly dominates. Or I mean, it's definitely better, not only for Alice, but also for Bob in comparison to coal. And so coal is an inefficient outcome here. So the gas is the efficient outcome. Okay? So again, if the energy authority knew the true state, probably, it's like I'm not going to impose any criteria about what the outcome should be, but it feels like oil here is the best outcome. Gas here is the best outcome. Well, but don't forget, the energy authority or the municipality doesn't know the true state. So what is it going to happen? Well, one alternative, one institutional rule is that the municipality just makes a survey and asks Bob and Alice what they prefer, what they like. Well, the thing is, if Alice and Bob knows that whenever the state 1 is the true state, the municipality is going to build oil power plant, and when the true state is state 2, municipality is going to build a gas power plant. What's going to happen is that Alice, is she ever going to tell the truth? Well, if true state is state 1, if you look, gas versus oil. If true state is state 2, gas versus oil. So just focus on these two outcomes, gas versus oil, gas versus oil. So as you see, Alice, regardless of the true state, prefers gas power plant over oil power plant. So what does that mean? That means if the true state is state 2, yes, she's going to tell the truth. She's going to say, hey, you know what? I actually prefer, I care about future. And so the true state is state 2. So you should build a gas power plant. However, if the true state is state 1, she's not going to declare that the true state is state 1. So what does that mean? That means if you, as the municipality or the power authority, conduct a survey, Alice will never say true state is state 1. She will always declare or answer the question, well, true state is in fact state 2. Well, what about Bob? Well, again, if you just look at those two outcomes, oil and gas, oil is better than gas for Bob in state 1, and oil is better than gas in state 2 as well. So this time, Bob always prefers oil power plant to gas power plant. So whenever you ask Bob, what is the true state, Bob, tell me, he will always say what? Well, here, if he says if he says here true state is state 1, he knows he's going to get oil. But if he says the true state is state 2, he knows he's going to end up getting gas. So therefore, Bob will always say, hey, you know what? The true state is state 1. So the bottom line is if you actually run a survey and ask these two guys, Bob and Alice, what is the true state? Alice is going to always report the true state is state 2 because she actually prefers the gas over oil. However, Bob is going to say, well, you know what? True state is state 1. Again, regardless of what the true state is, they're going to declare this way. So what does that mean? That means if the energy authority or the municipality conducts a survey, there's no way the energy authority can learn the true state from the participants. So that's a terrible mechanism. It means you can't really achieve the good outcome. All right? So what is the alternative? Well, alternative is the following. There is, in fact, a mechanism, a game, where the participants are going to tell the truth. All right, so here is the part where things are going to get a little bit more complicated. So the mechanism designer can actually build a game. All right, so let me write it here. So in this game, the mechanism designer says, Alice and Bob, please select one of two actions, up, down, up, down. Okay? Well, they are completely random actions, right? Up and down. It's like, what the heck does that mean? Well, the thing is, those actions are going to lead to outcomes that you're going to care. So if you both choose up and up, well, I'm going to build an oil power plant. All right? Well, what about the true state? I don't care about the true state, the mechanism designer will say. I'm going to build oil power plant if you both choose up. So you are going to play a simultaneous move game. You and Alice and Bob simultaneously and independently, without knowing each other's action, are going to choose one of two actions, up or down. That's it. It's very simple. I'm not going to ask you the true state or anything. But the thing is, if you both choose up, I'm going to build an oil power plant. If, however, you both choose down, I'm going to build a gas power plant. If Alice chooses up and the Bob chooses down, I'm going to choose coal power plant. And if Alice chooses D but Bob chooses up, I'm going to build a nuclear power plant. All right? That's it. You can say, all right, so let me take this. So this is the mechanism. Okay, let's have a closer look at this mechanism. So this is a mechanism where Alice and Bob play some game which sounds like has nothing to do with the true state, right? Nobody asked them what the true state is. They're supposed to choose, some two weird actions, up and down. Fine. But the thing is, the mechanism designer built this game and in such a way that, this is what I'm going to argue next, whatever the true state is, those guys are going to choose their actions or strategies in such a way that the outcome is going to be oil if the true state is state 1, and the outcome is going to be gas if the true state is state 2. Well, how do I know that? Well, let's show this. Remember, there are two possible state of the world. It could be state 1 or it could be state 2, where the energy authority doesn't know that. So let's suppose it is state 1. Okay? All right. Well, if state 1 is state 1, if state 1 is the true state, and if this is the game, Alice, don't forget, both Alice and Bob knows that the true state is state 1, all right? So there's no informational asymmetry or incompleteness for Alice and for Bob. They know the true state is state 1. So in this case, in this game, what is going to be the outcome? Well, we studied game theory for the last few months. So let's use one of the equilibrium concepts that we learned. So let's use the Nash equilibrium as the solution concept in this game. Okay? Sure, we can do that. So let's suppose Alice and Bob are going to choose their strategies in such a way that the outcome is a Nash equilibrium outcome. So the question is, what is the Nash equilibrium outcome of this game? Well, look, it's simple. Well, the payoffs are, here we don't have payoffs, but we do have preferences. So I can find the Nash equilibrium here. How so? Well, first, let's look at what happens if Alice chooses U. What is the best response for Bob? So Alice chooses U. So Bob has two actions, U or D. If he chooses U, he knows he's going to get oil. If he chooses D, he knows he's going to get coal. So which action does he prefer? Well, U or D? Well, oil or coal? Well, remember the true state is state 1. So if he chooses U, he's going to get oil. If he chooses D, he's going to get coal. And so oil is better than coal. That means his best response is going to be U. All right? So if Alice plays U, Bob's best response is playing U. Okay. Well, let's check the other way around. What if Bob plays U? What is the best response for Alice? Well, if Bob plays U, Alice knows that oil power plant will be built if she chooses U, or nuclear power plant will be built if she chooses D. Oil versus nuclear power plant. She prefers oil over nuclear power plant, so therefore she's going to choose U. So U is a best response to U for Alice, but also U is a best response to U for Bob. So therefore, in state 1, UU is a Nash equilibrium. Question is there any other Nash equilibrium in this game? Well, let's check. Let's suppose Alice plays D, okay? Well, that means Bob is going to get either nuclear power plant by choosing U or gas power plant by choosing D. However, we know that nuclear is better than gas, and so therefore Bob is going to best response by playing U. So U is a best response for Bob if Alice plays D. Okay, well, what else? Well, now let's look at if Bob plays U, what is the best response for Alice? Well, remember, if Bob plays U, the best response is U, not D. So therefore, DU will never be Nash equilibrium. Well, similarly, DD will never be Nash equilibrium because given that Alice plays D, D is not a best response, U is a best response. And finally, UD will never be Nash equilibrium because given that Alice plays U, the best response for Bob is U. All right, so therefore, in this game, all right, given that the true state is state 1, UU is going to be the only Nash equilibrium. So therefore, what is UU? UU corresponds to oil. So if true state is state 1, Alice and Bob are going to play this game in such a way that they will end up end up with a Nash equilibrium, in which case the outcome is going to be building the oil power plant. All right. Well, what about state 2 is the true state? All right. Well, let's again find the Nash equilibrium of this game. Well, when Alice plays U, Bob knows that he's going to end up choosing U or D, yes, but the U is going to end up with oil and the D is going to end up with coal, and he prefers oil to coal, so therefore his best response is going to be U, all right, not D. Okay, well, what about Bob playing U? What is the best response for Alice? Well, if Bob plays U, Alice is going to play U and get oil, and D and get nuclear power plant, and clearly she prefers D. So, you know what? The best response to U for Alice is D, not U. So UU is not a Nash equilibrium. All right? Well, what about UD? Is UD Nash equilibrium? Well, let's check. Well, given that Bob plays U, D was a best response. But what if Alice plays D? What is the best response? Well, if Alice plays D, for Bob, it's either nuclear power plant by choosing U, all right, nuclear, and gas by choosing D. And clearly Bob prefers gas to nuclear power plant. So therefore, for D, D is the best response. All right? So once again, if Alice plays D, Bob's best response is playing D. All right? So therefore, DU is not going to be a Nash equilibrium. Oh, by the way, UD is also not Nash equilibrium because if you remember, once Alice plays U, right? Once Alice plays U, oil versus coal, oil, it was the best response, meaning U was the best, so D is never a best response. So therefore, UD can never be Nash equilibrium. So there's only one remaining alternative, DD. Is it a Nash equilibrium? Well, when Alice plays D, D is the best response for Bob. And when Bob plays D, Is it D or U best response? Well, coal versus gas. Coal versus gas. Gas is better. So therefore D is the best response for Alice. So once again, not once again, if the true state is state 2, well then DD is the only, I mean here as well, is the only Nash equilibrium of this game. And the outcome is therefore DD, which is going to be gas power plant. Okay? As requested, not requested, as desired, that oil power plant in state 1, gas power plant in state 2. So once again, this is a mechanism where the mechanism designer, the energy authority, doesn't care about the true state. He doesn't need to know the true state because he designed the game in such a way that those guys, Bob and Alice, who know the true state, are going to play this game, and hopefully they're going to end up playing Nash equilibrium, and so that they are actually going to be indirectly revealing their preferences. All right? So I'm not asking those guys directly what the true state is, but I'm designing a game where they indirectly reveal their preferences. You see what I mean? The question is, how did we come up with this mechanism? I mean, where is it coming from? Can we generate those type of mechanisms in all environments? Or in what type of environments we can generate? And in fact, more importantly, how do we really create those mechanisms? I mean, where does this coming from at the very first place? It's like, is it falling out of sky, out of nowhere? No. So this is what we're going to do for the next of this chapter. We're going to formalize the mechanism design problem in a generic environment, and then we are going to talk about how we create such mechanisms in environments that you can think of. So this is what we're going to do next, okay?